Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this lecture on time and work. So in this lecture, we are going to solve 18 problems, practice questions on time and work. So let us get started with the first question. A is thrice as good a workman as B. C alone takes 48 days to paint a house. All three, A, B and C, working together takes 16 days to paint the house. How many days it will take for B alone to paint the house? So, solution, let the efficiency of B is X and hence the efficiency of A will be 3X. So, this thing is given to us in the question which says A is thrice as good as B. So the time taken by A to complete the task is unknown to us. B is also unknown and C takes 48 days to complete the task, that is painting a house. And together A, B, C takes 16 days to paint the house. So as usual, take the LCM of 48 and 16. So it will be 48. And we have assumed that the efficiency of B be X. So A will be 3X, correct? And we can find the 1 day work done by C by dividing LCM by a time taken by C, that is 48. So 48 upon 48 will be 1. So it is also given that the 1 day work done by combined all of these three is 3. So that means the sum 3x plus x plus 1 is equal to 3. That means x is equal to 1 by 2. Therefore, time taken by B alone to paint the house will be 48 upon 1 by 2, that is 96 days. So the option correct here is option C. Now, moving to question number 2. To do a certain work, the ratio of efficiency of A to that of B is 3:7. Working together, they can complete the work in 10 of 1/2 days. They work together for 8 days. In how many days? 60% of the remaining work will be completed by A alone. So let us have a look over the solution. So the ratio of efficiency of A to B is given in the ratio that 3:7. And time taken by A and B together is 10 of 1/2. That means 2 times of 10 plus 1 upon 2, that is 21 upon 2. So the total work of A plus B will be efficiency of A plus B. Okay. And time taken by A plus B. So the efficiency of combined A plus B will be the sum of their ratios, that is 3 plus 7, that is 10. So the total work will be 10 times of 21 upon 2, that is 105. So they work together for 8 days. Hence, work done by A and B in 8 days is equal to 10, that is the combined work efficiency, and 8 days, that will be 80 units of work is completed by A and B in 8 days. And now, how much amount of work is remaining? That is the total work that has to be done minus the work completed by now. So that will be 105 minus 80. So the correct answer for remaining work will be 25. So, but in the question it asks in how many days 60% of the remaining work will be completed alone. The remaining work is 25 units. So what is the 60%? of 25 units. That is 25 times of 60 upon 100. That is 15 units. So now the question changes, which says how much time will A alone take to do 15 units of work. So this is the question now. So it is time taken by A to complete 60% of remaining work is 15 upon 3, that is 5 days. So the correct option here is option C. Now, question number 3. P can work thrice as fast as Q. So the relation between P and Q, efficiency of P and Q is given to us. Working independently, Q can complete a task in 24 days. So in how many days can P and Q together finish the same task? So let us have a look over the solution. Now, it is given that P can work thrice as fast as Q. That means if the work efficiency of Q is 1, that is, if Q can complete 1 unit of work in a single day, then P will do 3 units of work in a single day. Okay. And now it is also given that Q can complete a task in 24 days. That means Q equal to 24 in this time section, and combined they can do it in, that we have to find out. Okay. So the total work efficiency of P and Q combined will be 3 plus 1, that is equal to 4. Okay. So P plus Q is equal to 24 upon 4. So 1 day work efficiency into time equal to total work. So this is the formula that we already know. So for Q, the total work will be 1 into 24, that is 24. So the time taken by P and Q to finish the same work will be 24 upon 3 plus 1, that is 6 days. So the option correct here is option C, 6 days. Moving to question number 4. A is twice as good a workman as B, and together they finish a piece of work in 22 days. In how many days will A alone finish the work? So let us suppose the efficiency of B be 1. Therefore, the efficiency of A is going to be twice of B. That means efficiency of A will be 2. So also it is given that together they finish a piece of work in 22 days, and we have to find how many days A alone requires. So 1 day work efficiency of A will be 2, 1 day work efficiency of B will be 1, and combined their work efficiency is 3. And combined they complete a task in 22 days. So for A plus B, efficiency into time is equal to total work. Therefore, the total work will be thrice of 22, that is 66 units. So the total time taken by A to finish the same work will be 66, that is total work, upon the efficiency, that is 2. So it will be 33 days. So the option correct here is option D. Question number 5. Sunil completes a piece of work in 4 days, whereas Dinesh completes the work in 6 days. Ramesh does the work one half times as fast as Sunil does. So in how many days all three can together complete the work? So it is given that Sunil takes 4 days, Dinesh takes 6 days, and Ramesh complete the works faster than Sunil. And how much faster? One half. Okay. So that means the work efficiency can be obtained here. So the LCM is 12. That means total unit of work is 12. So the 1 day work efficiency will be 3 for Sunil, and 1 day work efficiency for Dinesh will be 2, and for Ramesh it will be 3 times of 3 upon 2. So this is obtained from here because the relation between the work done by Ramesh in a single day to that of Sunil is given to us. So that brings us to the number 4.5 units of work in a single day by Ramesh. So we are interested in combined work done. How much time will they take? So when they work together, their amount of work done in a single day is 9.5 units. So time taken, the efficiency of time taken by all the three together is equal to 12 upon 3 plus 2 plus 4.5. So that means 24 upon 19 days. So the option correct here is option D. Question number 6. If A and B can complete a piece of work in 6 days, if A can work twice faster than B and thrice faster than C, then in how many days C alone can complete the same work? So let the efficiency of C be 2. So using efficiency of C, we can obtain the efficiency of A and B. So the efficiency of A is equal to 3 times C. This is given in the question. And also it says efficiency of A is twice B. That means efficiency of A is 6 and whereas efficiency of B is 3. So the time taken by A is unknown, time taken by B is unknown, but C is 11 times, so 6 upon 2, that is 33. And the 1 day work efficiency of A is 6, B is 3 and C is 2. So the combined work done by A, B, C in a single day is 11. So the efficiency into time is equal to total work. So the efficiency is 11 and the time is 6. Therefore, the total work is 11 into 6, that is 66. So the total work that needs to be done is 66 units. And the efficiency of C is known to us. So we can use it to find out the time taken by C alone to complete the work, that is 33 days. So the option correct here is option B. Question number 7. A can do a piece of work in 12 days. So A takes 12 days, while B can do the same work in 9 days. Find the number of days in which they can complete the whole work if work on alternate days and A start the work. So this time question becomes really interesting and it's very different from whatever we have done till now. Till now, people used to work together so that they can complete the task faster, or some other type of cases in which A left the work after 5 days or something. So such kind of questions we have discussed. But in this question, it says A work efficiency is known, B also known, and what if they start working on alternate days, starting with A? So how much time it will take? So first of all, it is given that A is 12 and B is 9. So the total amount of work that has to be done is 36. And the 1 day work efficiency of A is 36 upon 12, that is 3, 36 upon 9, that is 4. So the sum of 3 and 4 is 7. So on first day, work is done by A, and on the second day, work is done by B. Similarly, third day, work is done by A, while on the fourth day, work is done by B. So in odd number of days, work is done by A, while on even number of days, work is done by B. So in 2 days, work done by A and B together is 7 units. So hence, in 2 into 5 days, work done by A and B together is 7 into 5 units. So now, 1 unit of work is remaining and 11th day, the work is done by A because in odd number of days, A works. So the 3 unit work is done by A, that is equal to 1 day, and therefore 1 unit work is done by A, that is 1 upon 3 days. The total time is 10 days plus 1 upon 3 days, that is 10 of 1/3 days. So the option correct here is option B. Let us now have a look over the question number 8. A and B separately can build a wall in 12 and 16 days respectively. If they work for each day alternatively starting with A, in how many days will they be able to build the wall? So again, A takes 12 days, B takes 16 days. So the total work that needs to be done is 48 units. So their efficiency for A is 4, efficiency for B is 3, and their combined efficiency is 7. So now, on the first day, wall is built by A, and on the second day, wall is built by B. So similarly, on the third day, wall is built by A, while on the fourth day, wall is built by B. So in odd number of days, wall is built by A, while on the even number of days, wall is built by B. And in second 2 days, wall done by A and B together is 7 units. And hence in 2 into 6 days, wall done by A and B together will be 7 into 6 units. So now 6 unit wall is remaining, and in the 13th day, the wall is done by A because in odd number of days, A builds the wall. So the 4 unit wall is done by A in the 13th day, and now 2 unit wall is remaining and 14th day, so B will build the wall because on even days B works. So the 3 unit wall is done by B, that is equal to 1 day. Therefore 2 unit wall is done by B in 2/3 days. So the total time taken will be sum of all these 3, and it will be 13 of 2/3 days. So the option correct here is option C. Question number 9. A, B and C can do a piece of work in 30, 20 and 10 days respectively. A is assisted by B on one day and by C on the next day alternatively. How long would the work take to finish? Solution. So A takes 30 days, B takes 20 days and C takes 10 days. So the total amount of work that has to be done is 60. So 1 day work efficiency of A is 2, 1 day work efficiency of B is 3, 1 day work efficiency of C is 6. So the combined work efficiency of all of these 3 will be 11. So on the first day, work done by A and B is 2 plus 3, that is 5. And on the second day, work done by A and C will be 8. So in 2 days, total work done will be 13 units. Therefore, 2 times of 4 days, total work done will be 13 into 4, that is 52 units. And in 9th day, 5 unit work done by A and B. Therefore, 57 units work done in 9 days. And in 10th day, 8 unit work is done by A and C in a day, and 3 unit work is remaining. So therefore, 3 unit work is done by A and C, that is equal to 3 upon 8 days. So the total time will be the sum of all these 2. That will be 9 of 3, 8 days. That is option A. Question number 10. A, B, C can do a piece of work in 20, 30 and 60 days respectively. In how many days can A do the work if he is assisted by B and C on every third day? So time taken by A is 20, B is 30 and C is 60. So the total amount of work that needs to be done is 60. So 1 day work efficiency of A is 3, 1 day work efficiency of B is 2 and C is 1. So the combined work efficiency is 6. So on the first day and the second day, work is done by A, and on the third day, A is assisted by B and C. So the total work done in the third day is 6. The total work done in 3 days will be 12 units. So work done in 3 into 5 days will be 60 units. So that means the option correct here will be option C. Now to question 11. 2 men and 3 boys can complete a work in 10 days, while 3 men and 2 boys can complete a work in 8 days. In how many days 2 men and 1 boy can do the same work? So in these type of question, firstly we find the relation between the efficiency of given variable. 2 man plus 3 boy into 10 is equal to 3 man plus 2 boy into 8. That is equation number 1. So 2 man equal to 7 boys. Putting these relation in the given equation, we have 7 boy plus 3 boy equal to 10 days. So putting the relation in equation 1, 10 boys can do a piece of work in 10 days. So we have to find the number of days 2 men and 1 boy. Putting these relation in the equation, what we have to find? We have to find the number of days in 7 boy plus 1 boy. So that is M1 D1 equal to M2 D2, and it will be 10 times of 10 equal to 8 into D2, that is equal to D2 equal to 12.5 days. So the option correct here is option D. Question number 12. 4 men and 6 women can complete a work in 8 days. 3 men and 7 women can complete the same work in 10 days. In how many days 10 women can do the same work? So firstly, we find the relation between the efficiency of given variables. So the 4 men plus 6 women times 8 is equal to 3 men plus 7 women into 10. That is equation number 1. So 1 man is equal to 11 women. So putting these relations in a given equation, 4 men plus 6 women will be equal to 8 days when we put the relation in equation 1. So the 50 women can do a piece of work in 8 days. So we have to find the number of days of 10 women. So it will be M1 D1 equal to M2 D2, that is equal to 50 times of 8 equal to 10 times of D2, that is D2 equal to 40 days. So the option correct here is option D. Question number 13. If 5 men or 9 women can do a piece of work in 19 days, in how many days 3 men and 6 women will do the same work? So in keyword or, relation between efficiency are given between different variables. So the 5 men is equal to 9 women. That is 1 man equal to 9 by 5 women. Putting these relation in what we have to find, that is 3 men plus 6 men. So it will be 3 times of 9 by 5 women plus 6 women equal to 57 by 5 women. So 9 women can do in 19 days. So 57 by 5 women can do it in M1 D1 equal to M2 D2. That is equal to 9 times of 19 equal to 57 upon 5 D2. So D2 will be 15 days. So the option correct here is option A. Question number 14. A man, a woman, and a boy can complete a work in 3, 4, and 12 days respectively. How many boys must assist 1 man and 1 woman to complete the same work in 1 day? So the solution, LCM taken by the individual people would be total work. So the LCM of 3, 4, 12 is 12, that is total work. And now the efficiency of man is 12 upon 3, that is 4. Woman is 12 upon 4, that is 3. And the boy is 12 upon 12, that is 1. So these are the efficiency of 3. So to complete the whole work in 1 day, the effective efficiency would be 12. So the effective efficiency of 1 man and 1 woman in a day is 4 plus 3, that is 7. So the remaining efficiency is 5. So the number of boys required is 5. So the option correct here is option A. Question number 15. If 1 man or 2 women or 3 boys can complete a piece of work in 88 days, then in how many days 1 man, 1 woman, and 1 boy together will complete it? So if number of days remain same like in this question for men, women, and boys, so it is clearly show that 1 man is equal to 2 women equal to 3 boys. So it means work done by 1 man in 88 days will be done by 2 women in 88 days. So this shows efficiency. So 1 man equal to 2 women. So that means 1 man equal to half a man. Similarly, 1 boy is equal to 1 by 3 man. So 1 man plus 1 woman plus 1 boy will do work equal to 1 man plus 1 by 2 man plus 1 by 3 man equal to 11 upon 6 man. So 1 man complete a work in 88 days, then the number of days in which 11 by 6 men can do in is M1D1 equal to M2D2. That is equal to 1 times of 88 equal to 11 by 6 D2, that is D2 equal to 48 days. So the option correct here is option C. Question number 16. Either 8 men or 17 women can paint a house in 33 days. Number of days required to paint 3 such houses by 12 men and 24 women working at the same rate. The solution: efficiency of 8 men is equal to efficiency of 17 women, and efficiency of 1 man is equal to efficiency of 17 by 8 women. So 12 men and 24 men is equal to 12 times of 17 by 8 plus 24 women, that is 99 by 2 women. Now 17 women can paint a house in 33 days. So 99 by 2 women can paint 3 such houses in M1D1 upon W1 equal to M2D2 upon W2. So that is 17 into 33 upon 1 equal to 99 upon 2, that into D2 upon 3. So D2 is equal to 34 days. So the option correct here is option B. Question number 17. 24 men can do a piece of work in 12 days. If they work 8 hours per day, find the number of days in which 36 men can do 6 hours per day. So the relation between all the variables is M1D1 H1E1 upon W1 equal to M2D2 H2E2 upon W2. In this question, we have 3 variables: men, days, and hours. Hence, taking these 3 variables and draw the formula, we have M1D1 H1 equal to M2D2 H2. So M1 is 24, D1 is 12, H1 is 8, M2 is 36, D2 is unknown, and H2 is 6. So putting these values in formula, I will have 24 times of 12 times of 8 equal to 36 times of D2 into 6. So the correct answer here is 32 by 3 days. So the option correct here is option D. Question number 18. 36 men can do a piece of work in 8 days. If they work 6 hours per day, find the number of days in which 24 men can do half work if they work 8 hours per day. So the relation between all the variables are M1D1 equal into H1E1 upon W1 equal to M2D2 H2E2 upon W2. So putting the values of variables given in the question, M1 equal to 36, D1 equal to 8, H1 equal to 6 and W1 equal to 1. So M2 equal to 24 and D2 is unknown to us, H2 is 8 and W2 is 1 upon 2. So the solution is 36 times of 8 times of 6 upon 1 equal to 24 times of D2 times of 8 upon 1 upon 2. So D2 will be 9 upon 2 days. So correct option here is option C. So that would be all for this lecture, and I recommend you to try these problems on your own and try to solve them. And I'll see you in the next lecture with more problems on time and work.